Hello and welcome to this walkthrough. I am Abdullah Kasanoglu. My student ID is 0381977. First, we're gonna walk through our carbon emission estimator application built in Java using object-oriented programming principles. First, I want to talk about the SDG 13, uh, which is climate action by helping user track reduce their carbon footprint through everyday choices like what they eat and how they travel. Here's a simple overview. Now we're going back. Right. Okay, so in this video, we'll explore the structure of our program, why we separated features into individual classes, how our design ensures modularity, reusability, and user engagement. We'll go module by module, but also show how everything connects into a complete, smooth experience. So why multiple classes? Uh, this is a common asked question. Why not just put everything inside one giant class? In real world software development, that's a bad idea. Keeping everything in the main class right here makes the code messy, hard to maintain, and impossible to test or reuse. Instead, we use modular class designs. We have a bunch of classes right here, where each class has one responsibility, just like how a kitchen has different tools. All right. So for the main Java here, it handles user navigation. Wait, yeah, handles user navigation. Um, Activity logger, which is right here, handles emission calculations, emission history, here, used with log savings and readings, emission visualizer, turns data into ASII progress bars. Uh, what is it? Carbon budget tracker manages user set emission limits. Tip visor, right, is here. Um, it's an eco checklist. Provides engagement and education. This follows a key OOP principle, separation of concern. Each class does one job well and stays independent. Now, for the main controller, here, starting with the main.java, this file acts like a main controller or the dashboard of the program. It displays a user-friendly uh, menu and waits for user input. This is done using a scanner and a do while loop. Um, why I do while loop? Because we want the menu to appear at least once until the user decides to quit. Right. Inside the loop, we use a switch statement here to route the user to different modules. This design makes it easy to add or remove features without breaking the whole system. By creating instances of each module up front, we keep them ready, initialized when the user needs them. Right? Now we go to the activity logger, which is the main parts of our code. Right. The activity logger class is responsible for calculating carbon emissions based on our on user activities. These activities fall into two categories: food consumption and transportation usage. Um, so we start by defining the file paths to two data sets that contain emissions values for food and transportation mode. Right, food and transportation mode. Then we prepare two hash maps to store this data in memory. Yeah, here. Mm, the constructor loads this data as soon as the class is initialized, and then uh, loads the data The load data method calls load emission data twice, once for food and once for transportation. Mm, Right. This method uh, reads each line from the file and skips empty lines or comments. Lines starting with the hashtag. The food or transport name is stored as a lowercase key, and the corresponding CO2 level value is passed into a double and stored as the value. Right. For the log and food emissions, we prompt the user to enter a food name. It is converted to lowercase to match the keys into the food map. Um, So if the input doesn't match any available food item, we gracefully exit the method and ask them to retry. Right. This section right here, forgot I'm using the mouse. This section validates that quantity is a number. If not, prompts the user again, gives them a prompt. Right. Mm. Um, so here we have a basic check to avoid any negative numbers or zero quantities. Now we calculate um, the total emissions. We multiply the amount entered by the emission value per kilogram um, and display the results. Then we call save log method in the emission history to record it. A similar method exists for transport emissions with only small changes like kilometers instead of kilograms. Let's go for emission history. All right. This class is responsible for two key actions: saving a new emission entry for to the history log, displaying all previous logs when requested. Let's break down the save log first. Um, heat. Right. We use the buffer writer to efficiently write text to the file. The file is opened in pen mode, so existing entries are preserved. We format the current date time using the simple date format for clarity. The line includes all data sums categories, food or transport, item name, quantity, and total CO2 emitted. This ensures every log is permanently recorded for future tracking. History. Right. This method um, this method checks if the log file exists and it isn't empty. If there's nothing, it notifies the user. Okay, right. If there are records, it uses the buffer reader to loop through each line and prints them. This function is simple but important. Gives a gives the user a full view of the logged emissions across sessions. Um, Let's move on to the carbon budget tracker. This module um, lets the user define a personal CO2 emission goal or budget, then shows how much of it has been useful for based on the logged emissions. So here's how it works. Here um, we prompt the user to enter a CO2 budget. This becomes the emission goal. Next, we calculate the total emissions from the previous goal. Uh, we loop through the emission log line by line, extract the CO2 value from the fifth column of the log and add it to our running total. We then compare the user's total against the budget. If the user is still on the budget, we show how much room they have left. If not, we warn them if they exceeded it. Yeah. Um, this module introduces a behavioral feedback loop by showing users how close they are to personal targets. It encourages them. It encourages climate conscious decision making. From a technical perspective, this is a great example of data parsing, loop-based accumulation, and conditional reporting. Now we move on to um, the emission visualizer. Right. Um, the emission visualizer takes the emission budget comparison a step further by turning it into a visual progress bar using the ASII characters as aforementioned. This gives the user an immediate intuitive sense of how much their budget, um, how much of their budget they have consumed. Is this right? We define the total bar as 20 characters. They will represent 100% of the user's CO2 budget. We calculate the user's bar length based on how much of the budget the budget has been consumed. For example, if 50% of the budget is used, the bar will be 10. All right, move on to the tip advisor. So for the tip advisor, just basically it um, prints out different tips at randomly, which will be used when the user is to um, prompted to give or receive tips, and then if yes, he will be prompted again if he would like another tip. Right, let's go to the eco checklist. Right. So basically, we'll ask similar questions. Um, it's a checklist of how much wasting a user might do in their normal day-to-day life. Here's a checklist, and these the questions that will be asked. The user will input yes or no to these questions, and then um, the user will be prompted You have completed this amount of action, eco action today. Um, and yeah, these messages will be printed out as congratulations or congratulating the user of the amount of eco actions they did. Right, let's now look for local. Right, here's actually implementation. So basically, so, right. So we have both log food emissions and log transport emissions. Both of them are on the log. Keeps them visually appealing to the user. Now we have history and budget. It basically shows the user the emission history, the questions. Here you can clear the history, can put the budget, and then view the budget progress bar, daily eco action list, and the eco-friendly tips. Let's start with the log food emissions. Right. So now we'll be prompted with each kind of um, food that the user might be eating in the day-to-day life. So let's input um, chicken, right? The amount, obviously in kilograms. Let's say have 3 kilograms chicken, right? So it will say estimated CO2 emissions 20 kilograms. All right. So so log transport emissions basically will be prompted to give what transportation method did you use? If let's say the user says a motorbike, right? Say right in kilometers. Let's say 50, right? Say the estimated CO2 emissions is 9 kilograms. All right. Let's try another one. Let's say maybe plane. Hmm, maybe 2,000 kilometers. Right. 500 kilogram of CO2 emissions. Right. Let's view our emission history for the questions. Right. We've asked about chicken, motorbike, and plane. Right. Let's clear them. Sure, I want to clear. Yes. Then let's look at them again. Right. Emission log history, no logs found. Alright. Let's check carbon emission budget. Into weekly, let's say 200 kilograms for transportation and varying food items. Right, have not exceeding the budget. 200 kilograms of rain. Um, view carbon budget progress chart. Right, budget. Let's say I've used 150 kilograms. Right. All right. All right. Now for the daily eco action checklist. Right. Turn off to use unused lights. Not really. Use public transport if walked. Yeah. Avoid single use plastic. Not really. Eat a meat-free meal today. Um, nope. Take a short shower. I usually like to say shower. Recycle something today. No, not really. Used A reusable bottle, yes. Use eco-friendly electronics, which are implied LED lights. Yes. Right. I've completed 4 out of the 8 eco actions today. Let's go to the eco-friendly tip. Right. Is that your home? Thermostat fuel. Be lighting the tip. Yes. Use reusable bags, bottles, and containers. Right. Let's do another one. Take shorter showers to save water and energy. And last one. Recycle properly and reduce single-use plastics. All right. I think we're done now. Um, um, This project is a clean demonstration of object-oriented programming. Each class focused on the main loop ties uh, uh, the main loop ties them together. We use Java tools properly, scanner, hashmap, buffer reader, random, and other tools. Visual and educational features making it engaging. And yeah, right. This has been Abdullah out.